Hello, this is Nyanshta Sairam, roll number 21951 A0552, and this is my COA Techtalk. And my topic is Virtual Memory Management in the VAX or VMS operating system. Introduction. The VAX 11 by 70 introducing in 1978 and the smaller VAX 11 by 750 introduced in 1980 or digital equipped corporation's first implementation of the 32-bit VAX 11 mini computer architecture. Eventually, there will be family of VAX mini computers. The VAX 11 and VAX or VMS operating systems are designed to provide extended address space and enhanced performance for the digital PDP 11 customers. Built on, built on digital experience with the multitude of the PDP-11 operating systems, VAX or VMS were intended to provide a single environment for all VAX-based applications, whether real-time, time shared, including program development or batch. In addition, VAX or VMS had to operate on a family of processors having different performance characteristics and physical memory capacities ranging from 250k bytes to more than 8 megabytes. To meet the requirements posed by these applications environments, the memory management systems had to capable for adjusting to the changing demands characteristics of time sharing while allowing the predictable performance required by the real time and the batch process memory management policies and decisions made in the design and implementation of the first release of VAX or VMS operating systems in 1978. Reflected by the concerns of the developers, this article examines those concerns and mechanisms selected to the detail with them. VAX learn hardware. The basic entity in VAX systems is the process. Each process has a byte addressable 32-bit virtual address space, which is divided into 5 byte pages. A 32-byte virtual address contains a 12-bit virtual page name number and a 9-bit of offset within the page. The page is basic unit of mapping and protection on the under 2 bits of virtual address divided by the process address space into a number of functional regions or spaces. Figure 1 shows the division of the address spaces into the system wide and per process segments. And you can see the diagram on the screen. This is the VX processor virtual address and virtual address spaces. Address half of the address space bit 32 equals 1 is known as system space and is shared by all processes in the system. This is a system space virtual address generated by any process will be accessed the same physical memory locations. On the half of the system space is currently used by the architecture. The low address half of the address space bit 32 is 0 is known as the process space and it's unique of the each process space is itself divided into two regions by bit. The 30 bit 30 of the virtual address, the lower address half known as the P0 or program regions grows towards the higher addresses as shown by the arrows in figure 1. The high address half VAX or VMS use of VAX 11 address space, the system space layouts per process space layout. Known as the P1 or control region grows toward the lower address. Each process therefore has two local segments offering two directional of expansions each region systems. P0 and P1 is defined as the page table. A VX11 page table is a continuous array of 32-bit long word page table entities. Each page table entry or PTE contains the following fields. 1. A valid bit that indicates that the page table entry contains mapping information. A protection field that indicates the privilege is required to read or write the page. A modified bit that indicates whether a write access has occurred to the page. A field used to operating system and the physical page frame number that locates the page in physical memory. If the valid bit is 0, all the other bits with the complexity of the production field can be used by the software because of the hardware checks protection for a page whether not the bit in set. An illegal access to the page cannot cause a page to be loaded. Each page table is defined by the two hardware registers, a base address register and a length register. The page table of system space called system space table is located by the reference to the table page table base register which contains its physical address. The P0 and P1 page tables of the each process are located in the system space section of the address space. Therefore, the P0 and P1 pass table registers contains virtual address. P0 and P1 page tables can themselves be paged because of they are in virtual memory. The transition of page space virtual address involves two access one the system page table to calculate the physical address of the process page table and one process page table to calculate the physical address of the specified element. Since P0 and P1 page tables are specified, the corresponding base and length registers are calculated by the process content switch. The system page table, because it is shared by the all process, is not affected by the content switch. The VX hardware provides a translation buffer for coaching the virtual to physical translations to multiple references to a page table in a sequence memory are used avoided. The translation buffer is divided into two sections, one of systems translation, one for pre-process translation. The content switches occurs, the pre-process translation needs to be flushed. Use of address space by VMS or VX. As there are namely important, there the many address regions or spaces are used by VX or VMS for specific purposes. All executive codes and data including some process specific data structures and process page tables are stored in the virtual region. Figure 2 shows a layout of the system space virtual memory. The first few pages of the system space called the vector region contains provided to execute services routine in the system space. Service routines in the system space. Users call services routine through these fixed location vectors. This calls scheme allows routines to be reallocated in the later operating systems releases without affecting user programs. Thus, the VMS operating system is shared implicitly by all processes in the system. User call operating system service routines as they would call any user written procedure. The operating system is protected through the memory management system, which uses a hardware access mode mechanism. Elective code and the data are not made accessible to programs executing in the least privileged mode. VMS then in collection of the procedures that exist in the address space of the each process. The procedures can be called expletive. For example, the exception of the page fault occurs implicitly before the services are up because the operating system does not have specified address content. A content switch is can occur while a process is executing within the executive. Several processes can be executing simultaneously with the operating system. And VMS uses the P1 controlling region to store process specific data as well as the spot imaging command interpreter as shown in the figure 2b. The command interpreter executes within this region so as not to disturb user program images, and the user stack is located in the low address part of the PA tension and grows towards the lower address, and the PA region contains fixed stacks of by executing code that remains of the behalf of the process. Memory management implementation. Most of the main framework systems, including a special hardware such as fixed heading package systems, to enhance the page performance of the virtual memory systems. Many computers, in the contrast, often provide inadequate hardware provides for virtual memory operations. Moreover, there must be support the wide range of hardware implementations. Therefore, the VAX or VMS memory management systems had to be able to operate on the hardware configurations having small inexpensive CPUs, slow moving head disks, and the small memories. In the light of the requirements posed by these low end systems, the designs of VMS are concerned with a number of problems typically encouraged in a paging systems. Their major concerns is included the effect of one or mere heavily paging programs on other programmers in the system, the high cost of the program startup by the restart time in virtual memory environment that requires a program to fault its way into the main memory. The increased disk workload caused by paging and the process time consumed by such page lists in operating system. These problems are only amplified by the constraints of the mini computer hardware. To manage the problems, the VMS memory management system is divided into two pages components, the pager and the swapper. The pager is operating system procedure that executes as a result of a page fault. It executes within the content of the faulting process and this is responsible for the loading and removing process pages into and out of the memory. The snapper in the separate process responsible for the loading and removing a entire process into the out of the memory. The pager, the first decision concern listen about the effective heavy faulting programs on the other programs in the system. Some paging system are rule replaced politics whereby the fault can be caused removal of the programmer's pages in the scheme. The pages usually selected by for removal and those least recently used on a global basis. The trades of we are made braver used reducing process usage at the possible cost of increasing memory requirements. That is, the page of not referenced for the long time, the RLU page is removed. When started, the affected program must false these pages back into the memory one at a time. In attempt of the limit the effect of the heavily faulting process of on other processes in the system, VMS or VAX uses a process local page replacement policy. That is, when a page must be removed from the memory, the page to be removed in the selection from the process requesting a new page, a limit is paged the amount of physical memory a process may occupy. The set of pages currently in the memory of the process is called the resident set, and the resident set limit maximum size of the resident set. For each process, the pager maintains a data structure called the resident set list that describes the pages contained in the process that resident set. When a new program is started, its resident set is initially empty. As the program executed, the pages are loaded into the resident by the pager. Whenever a non-resident page is referred, when the resident set limit is reached, the fault processing must release a page for easy newly faulted page added to be its resident set. The pager uses simple first in first out replacement with the resident set into the pages to remove, that is queue operations. In most virtual memory systems, the reference between the table entry is set wherever the page is referred by the periodic trial of the reference bits and remembering when each of the last set. The operating systems can keep tracking of the relative age of each page. Other referencing between schemes such as clock do not reference a required complete scan of the all reference bits. The VMS designs, however, the concern about with the cost of the reference bit scanning for extremely large programs on slower processors with the limited physical memories. The computation time required for the search process page in the support for more sophisticated algorithms might be prohibited provided and since it is easier to acid more memory than its increasing trade-offs process cycle trade-offs were the made in the favor of reducing process using at the possible cost of increasing memory requirements. Therefore, the amount of computing requirements of the pager is limited. A quick decision is made, and a software coaching is mechanism is used to reduce the penalty of removing a page that is still in use. In addition to overhead is requirement to maintain well-behaved programs executing in a sufficient physical memory. When a page is removed from the process reference set, it is placed on one of the two pages list. The free page list of the modified list, it is modified bit is 0 in the page table entry. A copy of the page still exists on this, and the page is added to the tail of the free list. If the modified bit in the table entry, the page is one of the page that changes into must be written the page file. Such a page is queued on the tail of the modified page list. The data is stored from the obtained from the fountain places approximately millions refer to the 359 pages, although different slightly VMS in the secondary and the global. The graph indicates the addition of the free list can reduce the fault rate in a strict FIFO replacement to the level attributability close to RLU. This effects has been demonstrated by other athletic and stabilization studies. This graph fault versus memory uses in Fortin completions. The largest gain in the read clusters of the page comes at the initial program execution when the fault rate is typically high. The executable programs is composed of the several segments. A segment is a set of virtual continuous pages with similar attributes. A user can specify a default cluster size of the each segment when the program is linked. The cluster size is maximum number of pages that pager will attempt to load at once. Normally, no cluster size is applied by the user, as the system by default is used. When the pager locates the page of the read and execute file, it determines the cluster size of the associated segment. The pager then checks to see whether the adjacent blocks are following the requested page or on this contained page that are adjuncted to its virtual memory. Since the linker products and preserve physically continuous X mutable files on the disk wherever possible, it's likely that several pages can be read and within the sync disk operation. It's fewer than non-continuous were found. The pages will check preceding pages and its segments. Finally, the pager allocates the required number of pages frames from the free page list and initiate one disk and the request to the add the chosen page to the region set. When the preparing of the operation modified the list virtual continuous from the processes, the write performed so the virtually continuous pages of the process will be written to continuously paging the first disk blocks. Whenever one of these pages faulted, the page will be allow the clusters read request from most paging systems attempt most pages systems attempt to write modify pages to paging file as quickly as possible in the order of recoverable spaces. However, by the delaying modify page write request to the modified page list mechanism, VMs or VAX relies for optimize. 1. The modified page acts as the cache of recently removed pages. It's a page of the list is referenced, it is returned to the process at minimum cost. When a write request must be performed, many pages can be written at once. The developer system typically returns about it 9 pages, 11 pages with a single write on the paging file. The pages can be arranged on the paging file so that clustering on the read request is possible. Because of the writes are delayed, many pages writes are extremely avoided because either the pages are faulted again or the programming terminates. In a similar way, the pages set the modified in the page table entry for the write table entry in the first location the extensible page from the point on the paging. The paging file is used to backup storage from the page. The pages are known as copy on the reference pages. The several processes are sharing executable file. Each process fault a copy on reference page will receive its own copy I had page. Conclusion. Virtual memory is a common technique used in a computer's operating system. Virtual memory uses both hardware and software to enable a computer to compensate of physical memory storages. Temporarily transfer data from the random access memory RAM to disk storage. Thank you.